Hello, hi everyone, welcome back to the channel and to the series where we are learning about tree data structures. So in this video lecture, we'll be learning how to implement the trees which we have learned in the previous videos. So what is a tree? It's basically a hierarchical data structure. So if we have, let's say, n nodes which are numbered from 0 to n minus 1, the tree will be something like 0, 1, 2, 3, 4, like this. Here the n is 5. We have 5 nodes which are numbered from 0 to 4. Okay, so this is the root node, this is the leaf node, and this is also a leaf node, this is also a leaf node. Basically the leaf nodes are the nodes which has degree as 1. Fine. Now in this video lecture we'll see how we can actually implement these trees. And basically this is a tree which has bidirectional edges. That means we have an edge from 0 to 1 and we have a edge from 1 to 0 edge as well. We can move from 1 to 0 as well as we can move from 0 to 1. So this is called a bidirectional edge. We also have trees where we have unidirectional edges. Like we have tree like this, same number of nodes, let's say 5 nodes, 0, 1, 0 to 2, 0 to 3, and 1 to 4. In this tree, we have a directed edge from 0 to 1. We have a directed edge from 0 to 2. We have a directed edge from 0 to 3. That means we can just go from 0 to 1, but we can't come back. We can't traverse node number 0 starting from node number 1 in this tree. There is no back edge basically. Okay, so how we can implement these trees? Let's see that. Basically we use two types of techniques. The first is using adjacency list. So how we declare a adjacency list for a tree, for a typical tree having n nodes, and the nodes are numbered from 0 to n minus 1. How we can implement it? So let's see. The implementation is simple. We just try it like this. The implementation is in C++, vector int tree n. So this will create a tree which has n nodes numbered from 0 to n minus 1. So this is adjacency list. Fine. So let's see how it actually stores the tree, how we can actually store the edges in this adjacency list. So let's take an example. Let's take this tree. We have tree like 0, 1, 2, 3, 4. So the case is same as with graphs, because trees are also special cases of graph. So if you know how to implement graphs, you probably know how to implement trees, because we use the same strategy to implement graphs. Okay, now we can also use pointers to implement trees, but that we'll discuss in the next videos or upcoming videos, or in some other series if required. But for now, just learn about this implementation, that is using adjacency list, as well as the second implementation, that is using adjacency matrix. Now here in this, to store this tree into an adjacency list, we create an adjacency list of 5 nodes, because we have 5 nodes in this tree which are numbered from 0 to 4. Okay, now how to create these edges? The edges can be created like this. So first of all, we have an edge from 0 to 1, and it is a bidirectional edge. So that's how we create it. Tree 0 dot pushback 1. This creates an edge from 0 to 1. Fine. So we'll have the adjacency matrix looks like this. The adjacency list looks like this. So we have nodes like numbered from 0, 1. Imagine it like this: 0, 1, 2, 3, 4. Now for every node we are storing a vector. we are storing a vector which basically lists out all of the nodes which are connected to this node 0 by a directed edge. So we have a directed edge from 0 to 1 which we have created here. So we store 1 here. For 0 we push 1. Now since this is a bidirectional edge, we also have to store an edge from 1 to 0. Why? Because we can move from 0 to 1 as well as we can move from 1 to 0. That's why we also store tree 1 dot push back 0. So we have an edge from 1 to 0. So we stored 0 for this node 1. Now this creates an edge between 0 and 1. Let's create an edge between 0 and 2. Tree 0 dot push back 2. So this create an edge between 0 and 2. So we store 2 here. Let's create an edge between 2 and 0. So there's an edge from 2 to 0. Push back 0. So from 2 to 0. So we store 0 for 2. So in this fashion we create bidirectional edges. Fine. So you got how we are gonna. So this is going to implement my tree. Now in the problem statement we'll be given array of edges like this. Edges 0 1 0 2 0 3, something like this. An array of pair of nodes, and will now the problem statement explicitly mentions that the edges are bidirectional. In that case we have to use this strategy to implement the tree or the graph. So the same strategy can be also used to implement graphs as well, because graphs like trees are special cases of graphs. Fine. So let's just implement this the tree in a code editor. Okay, so let's implement the graph. So here you can see that let's first declare a graph of, let's say, 5 nodes. Vector int. Let's basically declare a tree of 5 nodes. Vector int tree 5. Now the nodes are numbered from 0 to 4. Let's create edges. Let's just implement the same tree here, this one. So there is an edge, there is a bidirectional edge between 0 and 1. So create an edge. So let's implement the trees here. Let's implement the tree which we have learned here using the adjacency list, where we have bidirectional edges in the tree. So let's first input the number of nodes in the tree. Okay. Now let's input the edges which I want in my tree. So for that, let's create a vector of pairs to store those edges. So we will have n minus 1 edges, because we know that for n nodes we have n minus 1 edges. So we'll have n minus 1 edges. So let's iterate and let's input these edges. So we'll iterate for n minus 1 times, and for every iteration we're gonna take the edges as input. First edges I dot second. So this will store the corresponding pairs for the edges. Now let's create a adjacency list here. Vector tree n. Okay. Now in the problem statement we'll be given these two things. We'll be simply passed this array into a function, the edges array, and now we have to create the tree corresponding to those edges. So our work starts from here. Okay, so let's see how we can do that. Let's iterate over the edges. Edges. So for every edge, Let's create a bidirectional edge between the pair of elements. Push back edge 1, tree edge 1 dot push back edge 0. Fine, so that's how we create edges and our tree is prepared. We have our tree prepared at this point. Okay, now so let's move to the next type of trees where we have directed edges, like tree like this. So let's see how we can implement trees like this. For 5 nodes which are numbered from 0 to 4, we have an edge from 0 to 1, we have an edge from 0 to 2, we have an edge from 0 to 3, we have an edge from 1 to 4. Okay, like this. Now let's create the adjacency list for this tree. Now here the procedure is same. So we have 0, 1, 2, 3, 4. We have corresponding vectors for each node. And let's create this first edge between 0 and 1 from 0 to 1. So tree 0 dot push back 1. So this edge is created. Let's create an edge between 0 and 2, that is from 0 to 2. Tree 0 dot, so like after this statement is executed, we'll have 1 stored here. Now for 0 to 2, we'll have push back. Now we know that there is no like reverse edge from 1 to 0. We can just move from 0 to 1, but we cannot move from 1 to 0 directly. Okay, that means we do not have to push 0 for 1, because this is a directed edge. We just have an edge from 0 to 1 and not from 1 to 0. That's why we didn't write tree 1 dot pushback 0, unlike in the tree with directed in the undirected edges. So here between 0 and 2, that means for 0 we'll have 2 as well. We'll have 2 stored. Tree 1 dot pushback 4. So for 1 we store 4 like this. So in this fashion we are creating directed edges. Okay, so how we can implement it? Very simple. If you have learned the implementation in the previous case, it's simple. We'll be given these edges and now we just do this. From the first integer of the pair, create an edge towards the second integer of the pair, and we'll have our directed tree or directed graph prepared. Fine. This was the first type of implementation for trees. Let's move to the second type of implementation, that is adjacency matrix. Okay, so again let's first start with the tree with undirected edges. So we have tree like this: 0, 1, 2, 3, from 1 to 4. Let's create a matrix of dimensions 5 cross 5, because we have 5 nodes in this tree which are numbered from 0 to 4. So let's create a 5 cross 5 matrix. Zero, 1, 2, 3, 4. Same here. 0, 1, 2, 3, 4. Initialize this matrix with 0. Okay, we have 0 stored for every node. Okay, now let's just implement the graph. So we create this type of matrix, 5 cross 5 matrix or n cross n matrix, which for the tree which has n nodes. So let's traverse over the edges. For the very first edge between 0 and 1, find this 0, node number 0 on this side. Here. Find node number 1 on this side. Here. Find the corresponding cell. 0, 1 is this cell. Now mark 1 here, because we have a edge from 0 to 1. This creates an edge from 0 to 1. Now I want to create an edge from 1 to 0 as well. So find 1 here, find 0 here, and mark this cell, the corresponding cell to 1. Here I have created this edge, the edge between 0 and 1. Similarly, I'll create the edges between 0 and 2 like this. For 0, 2, mark here. For 2, 0, mark 1 here. Between 0 and 3, so 0, 3, mark here. For 3, 0, mark here. Same goes for 1, 4, 1, 4, mark here. 4, 1, mark here. Like this. So we have our tree prepared. Okay, so let's jump to the next implementation. That is, okay, let's first implement this in the code editor. So again, we'll be having the edges array given in the problem statement. We'll just have to create a matrix. So let's create a matrix. Let's call it tree of dimensions n cross n. Initialize it with 0. Now let's iterate over the edges. Edge, edges, and create the bidirectional edges thereof. So there is an edge, tree edge 0, edge 1, set it to 1. Also we have to set tree edge 1, edge 0 to 1, because the edges are bidirectional. Okay, so that's all. After that, after this for loop is executed, we'll have our tree prepared. Now why do we use adjacency matrix to store the trees when we have adjacency list? It's because there are certain problems which requires us to use adjacency matrix, and it becomes easy for us to solve those problems if we use this type of implementation. Okay, where the n is really less. Fine, so let's just see the second implementation for the trees, where we have a directed tree, the tree with directed edges. So we have a directed edge from 0 to 1, directed edge from 0 to 2, a directed edge from 0 to 3, and a directed edge from 1 to 4. Now here we create the matrix of dimensions 4 cross 4. Zero, 1, 2, 3, 4. 0, 1, 2, 3, 4. Initialize it with 0. Okay, initialize all of the cells with 0. Now let's create this first edge from 0 to 1. So find 0 here, find 1 here, mark 1 here. From 0 to 2, find 0 here, find 2 here, mark 1 here. From 0 to 3, find 0 here, find 3 here, mark 1 here. From 1 to 4, find 1 here, find 4 here, mark 1 here. We do not have to mark the cell 1, 0 for this edge. We just have to mark the cell 0, 1, that is row number 0, column number 1, and not the row number 1 and column number 0, because the edge is directed from 0 to 1 and not from 1 to 0. Okay, so that's all. That's how we implement directed trees, or the trees with directed edges. And here the change is simple. We just remove this statement, and that's all. Okay, so that's how we implement trees as well as graph. Implementation of graphs is also similar. we implement graphs using adjacency matrices and adjacency lists. This is just a special case for graphs, and I hope you learned something from this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and stay tuned with me for the further updates in the series, and I hope to see you all in my next video.